Is that pretty much what your first day encounters most of the time? Much teaching the first day? Mostly syllabus? You know, what is a syllabus? Syllabus is just a bunch of rules, right? The rules for the course, that's what it is. And it struck me like when my first son, my oldest son, went to preschool, half-day preschool, 3-year-old preschool. Okay? Drop him off, I pick him up, I'm like, hey Lucas, how did your first day go? He's like, good. And I said, well, what did you do today? He goes, well, Dad, it was a bunch of rules. That's what they do the first day. They tell you can't like pinch people and no like throwing things. That's the rules they have, different than our rules. But then it was 4-year-old preschool. Then we traveled a little further. We go a little further. He said, hey Dad, I said what? He said, in preschool they don't wipe your bum either. That must have been one of their rules. You got to wipe your own bum. That's starting at 3 years old. That's something you have to do. So, anyways. I gave you guys homework, but I know maybe some of you guys were still acquiring the book. So I'd like to go through that together, and then we'll move on to new material. So chapter 1 is what is statistics. We know statistics is a way to get information from data. We also talked about some terms. We talked about descriptive statistics, describing data. We can describe it as a number, as a graph, or as a table. And we talked about the process of statistical inference, where we take a sample statistic and make an inference about a population parameter. So I like number 4. That's kind of a good one to kind of find out what's going on here. A manufacturer of computer chips claims that less than 10% of its products are effective. When 1,000 chips were drawn from a large production, and it should say run in here, it doesn't say run, but it should, 7.5% were found to be defective. What is the population of interest? So, Mark, I'm going to pick one. What is the population? The population is always everything we're interested in studying. So, what are we interested in studying here, Mark? Chips. All of the chips, right? All of the chips. Not just this, but the whole darn thing. Yes? Yes, that's the population. What is the sample then? What is the sample? Sydney, what's the sample? 1,000. Very good. What is the parameter then? Roger, what's the parameter? 10%. Why, Roger? That's right. Why? Because 10% is what we believe about all of the chips, right? It's a characteristic of the population. So that means 7.5% is what? Stefan, what do you think? 7.5% is what? Then it is the statistic, right? So sample statistics are used to make inferences about population parameters. One more I'd like to do. So here's an example. Some of you guys are accounting majors, right? Anyone accounting majors in here? What is auditing? When you audit someone, what do you do? What are you doing when you audit someone?
Checking to ensure that they're doing everything right.
Okay. Right. So according to their processes, right? And when you go in to audit someone, maybe during the course of the year they've done millions of financial transactions, right? Can you look at every damn one of them? No, so what do you have to do? Take a sample, right? And if they claim something like, 4% of our transactions are duplicates, and you say, well, I did a sample of 1,000 and it's had 12% duplicates, what do you begin to think about their claim? You begin to think that their claim is wrong, right? So sampling is used a lot in the accounting world, in the auditing world in particular. I think let's do number 6 briefly here. It says, you're shown a coin that its owner says is fair in the sense that it will produce the same number of heads and tails when flipped a very large number of times. How could I test this claim? How could I test this claim? Andrew, how could I test this claim? If I gave you a coin and I said it's fair, you don't believe me because it's not very trustworthy, what would you do to test that out? You flip it a set number of times, right? That's a sample. 10, 50, 100, okay? So that would be the experiment you would try, okay? The population is, all the flips. The sample is, let's say I flip it 100 times. And if I flip it 100 times and it comes up heads 95 times, Eric, what do you start to think? What inference are you going to start to make?
That's not very
Right, you're going to say that could happen, right? But the probability of that is very, very low. So I think, if I flip it 100 times and it comes up heads 95% of the time, which is a statistic, right? I think that the odds that coin is fair is very, very low, so maybe you're willing to call me a liar. What if it comes up and it's heads 55 out of the 100 times? What do you think then, Rachel?
I mean, it might still be fair, it's a little less likely, but, it's not.
I don't have overwhelming evidence to say that it's unfair, right? I said, well, that could happen, right? 55 and 45 could happen. So you think about it, that's what we're doing when we take a sample. We say, look at this statistic, and can we make an inference about the larger population around? Yes? Use the rate deal in the world of business because we want to understand something, and we can't talk to every potential customer, every potential market, so we take a sample. So any questions on anything in chapter 1? We're going to close out chapter 1 then. Any questions? All right then. Let's move on to chapter 2. Okay, so the first thing we did in chapter 1 was we kind of defined what this field of statistics is all about and define some things. We're going to get into chapter 2. We're going to get into our first branch, our first subset of descriptive statistics, which is graphical descriptive statistics. But before we do that, we're going to have to define some things and understand some things. So, let's talk about those things first. And first off, some definitions. A value is some characteristic a variable is some characteristic of a population or sample. For example, there are many variables about each of you that I can study. I can study your height, that's a variable. Why is it a variable? Because it changes from instance to instance, right? You're Mark maybe 6'2", right? Maybe I'm 6'1", maybe Tony's 6'4", you know what I mean? It changes, right? It's a variable. We can study the variable weight. We can study the variable IQ. We can study the variable, how far you live from around, right? Variable is a characteristic that we're interested in studying. Now the values are the potential values of that data. For example, we talk about height. I don't know what the shortest person in the world is, but let's say it's 2 feet, and the tallest one might be 8 feet or something like that. So all those potential values are the values. If we talk about your exam score, the values are from 0 to 100. You can score a 0, you can score 100, and every value in between. That are the potential values that variable can take on. If we're talking about a major in a business world, the values are accounting, econ, finance, marketing, management, MIS, right? Those are the potential values. Now, what data is the actual observed values, right? When we talk about data, we say it's raw facts. Raw facts data is what we actually come up with when we take the sample or look at the population. Grades can be anywhere from A to F, but when we look at your grades, the actual data is, well, you scored a B here, an A here, a C here, an A here, an A here. That's the data, okay? So a variable is generally the characteristic we're defining. Values are the values that variable can take on, and data is what we actually observe. Now, Sticking with data, we need to understand the types of data. Before we start applying graphical statistics or numerical statistics, we need to understand the type of data that we have. The reason is statistics is a tool, right? So like any tool, I have to use it for its intended purpose. I can't use a hammer on a screw. That's not going to work. And I can't use a screwdriver on a nail. That's not going to work. So I need to understand the type of data that I have first so I can apply the proper statistical technique. In this class, we're going to define data in one of 3 categories. Okay, one of 3 categories. Interval, ordinal, or nominal. Okay, interval, ordinal, or nominal data. So let's talk about each of those. First off, interval data. Interval data is real numbers. You might be saying, well, what are real numbers? Well, we'll talk about what are non-real numbers when we get to nominal data. Interval data is real numbers like heights, weights, prices that the math makes sense for, right? If I say my salary times 10%, the math makes sense, right? Double my salary, it makes sense, right? The math works, okay? So real numbers with real meaning that the math works, math works. These are referred to, God bless you, as also quantitative data or numerical data. Real numbers, numbers that we can do math with, okay? The second type, so this kind of helps you decide, well, what is real numbers versus non-real numbers? The second type of data is nominal data. Nominal data, the way you want to think about that is categorical data. Gender is a category. You're either male or you're female, okay? You either live in Pennsylvania or Maryland. Those are categories, or all the other 50 states and territories, right? Those are categories you can fit into. You're either, religion is a category thing. So you're Catholic or whatever, okay? All those are categories. Now, sometimes with categorical data, for the purpose of codifying it, we assign a number to the category. For example, you may have seen something like, 1 indicates single, 2 is married, 3 is divorced, 4 is widowed. And those numbers only represent categories. They're not real numbers, right? You can't do math on them. You can't say, take widowed divided by 2 and get married. That doesn't make sense. So those numbers just kind of are placeholders. You know what I'm saying? They're not real numbers, okay? Nominal data, just also called categorical. I don't like the qualitative term, but sometimes we use that, because qualitative tends to mean words. And then the third type is a special type, and it's kind of an in-between deal. It is ordinal data, okay? Ordinal data is categorical, but there's an implied ranking to it. If you ever watch figure skating, my wife's into figure skating, so sometimes I watch it. It's not actually that bad. But they assign ordinals. Ordinals are rankings, like you're number 1, you're number 2, you're number 3 at this point. So at the end of this course, you're going to rate me as a professor. You're either going to say excellent, very good, good, fair, or poor. And they put numbers there, right? 1, 2, 3, 4, 5. But those numbers they're not quantitative numbers. I can't multiply fair by 2 and say that means, twice as good means you're good. Twice as good as fair is good. That doesn't make sense. So it's categorical, but there's definitely an implied ranking to it, right? Excellent is better than very good. Very good is better than good. Good is better than fair. Fair is better than poor. Small, medium, large. There's an implied ranking there, yes? Now, it has to be a universally understood ranking. For example, we can't say major is ordinal data. I mean, I know business major is better than a health science major, but that's not universally understood, right? So it has to be universally understood. Does that make sense? That's ordinal data, when there's a ranking to it. So, and we're going to do some of these so we can see this. What's real important in the world of statistics is we need to know what type of data we have, because that limits or adds to what we can do to analyze. And when we talk about this type of data, calculations are permitted on interval data, right? I can average it, I can take a range of it, I can figure out percentiles. We can't do anything on ordinal data except rank it. Say like, oh, you're 3 spots above number 5, okay? We can rank it. In nominal data, all I can really do is count the number of observations. That's it, right? So because I can do the most with interval, a little bit less with ordinal, and less even with nominal, this leads to like a ranking, like a hierarchy of data. Okay, and this is the hierarchy of data. Interval values are real numbers, all calculations are valid. And we can go from interval data down to ordinal or nominal. You know what I mean? We can convert interval data to ordinal data. Let me give you an example. At the end of this class, at the end of every damn class I've ever taught at St. Francis, I take interval data and make it ordinal data for every student. What am I doing? At the end of every class at St. Francis University, I take interval data and I make it ordinal. What am I doing? What's that? Not so much attendance. I mean, attendance is, you're right, it's interval data because you missed 5, someone else missed 10, twice as much. But I take interval data that I track meticulously all year and I convert it to ordinal data. Sir? Yeah, give me, so what do I do, sir? Your name is, I'm sorry. JR. You might have a 95, right? That's interval data. What do I convert that to? A is a category, but it has a ranking to it. A minus, B plus, right? That's ordinal data. So I take rich data, 84, 86, 87, and I make them all B, right? I take interval data and make it ordinal at the end of the class. You know what I'm saying? At the end of that is me going down this hierarchy. So values must represent, so we can go down the hierarchy, but we can't go up the hierarchy. So a couple things, and I'm gonna try something with you guys. You know, I'm always keeping in touch with like the latest, like how to reach students, right? And all the literature says the best way to reach students now is via this, right? You guys have one, everyone has one of these, yes? So we're going to do a little quiz. We're going to use this to do that little quiz. So what I'd like you to do is, if you have a cell phone, if you don't have a cell phone, you can go to this URL. But I want you to get out a cell phone, and hopefully it'll give you a message like, hey, you may get charged for this, but it's not going to charge you unless you're having a crappy cell phone phone. But I want you to text John Miko 510 to 37607. That's where you want to send the message to, John 37607, and then text John Miko 510, and it's all like together. And it should say, "Hey, you've joined Poll Everywhere." Or you can do it on, you got your laptop and do it. Is it working? Yes or no? Okay, thank you. I think we only have to do this once. Okay, you guys good? Did you join that? No, it's all together. See how it's all together? Yeah, it's just like a code. Yeah, 510, I don't know why 510. You should get a text back. You get a text back? I'm going to hear 1B. You guys all have your phone on like super secret silent, right? My 16-year-old, I don't think I've ever heard, I mean, he lives on his phone, but I don't think I've ever heard it go off. He has some kind of like secret ringtone, I guess. All right. So here's what we're going to do. I just activated this. So using that same thing that just texted you back, I want to know what type of data is zip code. So zip code would be like, we're in 15940 right now. If you're in Hollywood, I think, or it's 90210, right? What was that? Is that Hollywood? Yeah, Hollywood. Beverly Hills, that's even, yeah, okay. Portage is 15946. So what type of data is zip code? Okay, so as you respond, these are the responses coming in, A, B, or C. You're responding A, B, or C. How many responses? Does it show us how many responses I have so far? All right, so it looks like our responses are done. C, you're saying, huh? C is the correct answer. Why is it not? We have 23% of class, or yeah, 23% and 70%, that doesn't add up. But why is it C and not A? I think A was the most common and B not so much. So why is it C and not A? Why is it nominal data and not interval data? Rachel? The code is a category that shows you where you live, right? The code isn't like anything I can do mathematics with. I live in Portage, it's 15946. We're in Loretto, it's 15940. If I subtract Loretto from Portage, I get 6. 6 is like Brooklyn, right? If you subtract Loretto from Portage, I don't know what the hell you get, but it's not Brooklyn, right? So the math doesn't make sense, right? So it is definitely nominal data. So we'll do another one. Let's go to the next one. And what type of data is height? Doesn't matter if it's inches, doesn't matter if it's centimeters, doesn't matter if it is, if that's A, B, or C, to this. All right, they're coming in. Yeah. Sure. You're afraid to log in your response, JR?
Yeah.
Go ahead, give it to me.
Ordinal, is that in terms of power?
Ordinal is, there's a ranking of ordinal always, okay? It's a category with a rank. So like, numbers always have a rank, but they're interval, right? Real numbers are interval. Categories that can be ranked are ordinal. So this one is not ordinal, right? I know height can be ranked, like 6'1", but it's actually a real number, so the answer would be what? A. You guys got it right. So 92% got that right. Let's move to the last one, okay? What type of data is coffee size at Starbucks? And I get so mad every time I go to Starbucks. I just want to order medium, small, large, and they force you to use their Italian words. You know what I'm talking about? They make you feel like an idiot, you know? You know the size of mine? Something like that. Yeah, I just say, give me the biggest one you have. And then they force you, like, no, that means grande. I'm like, I don't care. It's a regular coffee. All right, so the answer to this is definitely what? The answer to this, because it's ranking, because it's a category, small, medium, large, venti, whatever the heck their other ones are, we're going to say it is ordinal because it's an implied ranking, right? It's categorical with an implied ranking. Let's do a couple others. So these I don't have set up with a thing, but I'm going to go to the book here and let's do number 1 on page 30, okay? You can look up here if you need to. It says, the placement office at a university regularly surveys the graduates 1 year after graduation and asks for the following information. For each, determine the type of data. What is your occupation? What is your occupation? So, they might say, doctor, professor, ditch digger, Starbucks barista, all those are occupation. That's the type of data that comes back. What would you say occupation is then? Tony? It is nominal, right? You may think that being a doctor is better than a barista, but that's not universally understood to be that way, right? So it has to be nominal. There's no universally understood ranking there. Even if it's blue collar, white collar, there's no ranking there. JR? What's that? No. If it was income, it would be what? If we said, what is your income? Which might be a question, that is the next question. That is what type of data? Interval data, because it's real numbers. What degree did you obtain? Now this one, it depends what type of data we get back. I would probably say, it depends on how you're thinking about it, it could be one of two. So what do you think? Eric, what do you think? What degree did you obtain?
I guess.
There's only one that's wrong, Eric, so.
Yeah, I was gonna say ordinal or nominal depending on how you look at it.
Very good, that's perfect, Eric. So if I'm thinking like associates, bachelors, masters, doctor, what would that be, Eric?
You're just going like the names.
If I'm using like the degree level, yeah, associates, bachelors, that would be ordinal because there is an universally understood ranking, but this takes more education than that, right? That takes, so that would be ordinal. But if I came back and said, if I give you major instead of like the degree, like biology, finance, what would that be? That would just be categorical. Very good. What is the amount of your student loan? Randall, what do you think this is? Amount of your student loan?
Nominal.
Not nominal. It is anytime we have real money, money is what? Money is always, money is interval, always. Money is interval because money is real, right? Money is real numbers. You can double money, you can 10%. Money, any money question is interval data. It's real numbers. How would you rate the quality of instruction? Excellent, very good, good, fair, poor. What do you think? It is ordinal data, right? It's categories, but the categories have implied rankings to them. And we often see this, we see this as, what kind of scale this is. A lot of times you see this on surveys. What's the name of the scale? It starts with an L. You guys ever hear of this term? It's a Likert scale. You guys ever hear of sometimes some people say Likert or Likert scale. It's a 5-point Likert scale. Do you strongly agree, neither, disagree? You ever see those scales? Those are all ordinal scales that people pick. Okay, some other examples I'll show you. Because data is awesome. If I go down here to material by chapter, chapter 2, we have several football, you guys can't see what I'm doing. We have several football players in here. There is a service, Jeff Sagarin, who's a statistician for USA Today. He rates college football programs all throughout the year, right? So this is all Division I programs. So let's find us. Okay. We are 185. I think, who was number 1? Was it Alabama? Did I see it top? I saw Alabama, Clemson, Ohio State, Oklahoma, all those good things. We are 185, okay, and I think there's 251. So, and I can tell you, you guys might say, oh, that's not so good, but I've done this exercise for like 14 years. Many a year, probably 10 out of 14, out of the last 4 or 5, we were last. And then they did, I kid you not, us and like Valparaiso. They're awful. So we're moving up in the world. You're right, we are. So 185 is what? What type of data is 185? It is ordinal data because it's a ranking, right? We know that we are 184 spots lower than Alabama. Now, one of the things that they come up with is they look at who you played last year, who you played this year, and all that stuff. They come up with a rating here, and it's a numerical rating. So what type of data is that? It's going to be numerical. It's what type of data then? It's interval. And the way you're supposed to use this is whoever you're playing, you take that number minus their number, and home team gets 3 points. So we play first who, guys? Oof. So Montana is 58.35. They are home, right? Montana's home. So we'll bump them up to 61 because they're home. And we are 42. So the point spread, predicted point spread by this method is 19. So you guys got to cover that, okay? You don't think so? Here's what I'm hoping. I'm hoping we play some of these guys down here at the bottom. Do we play any of these guys down here at the bottom? I hope we play like Arkansas Pine Bluff. Are they coming up to Loretto, I hope? No? Texas Southern, Mississippi Valley State. That's who I want. How about that school you guys played last year, that Faith University? Those guys aren't even a college. Do you know that? Oh my goodness. Other examples. This is old, but you may be surprised to learn this. They don't do this anymore. I think this was like 2011. But Sporting News always ranked the best sports cities in the United States every year. Dallas won this year, Boston, Philly, you see that. But you'll be surprised to learn that Loretto, PA made the list. It was 233. And the reason it was 233 is why? Well, the rankings they used were, they based it on a number of like professional sports contests in that city, how well they did, but also the number of Division I contests, in that city. And obviously, see, we're above Towson, Maryland, which is, much bigger. Niagara, Dover. Doesn't Dover have like a big car track? Grand Forks, North Dakota. So there we are, Loretto, Pennsylvania. Okay, the other one I always show, let me see, Miko. This site doesn't get used much anymore, but you guys don't use it anymore. It used to be used at one point. Rate my professors. So you can go in there and rate professors on a few things like clarity, overall quality, hotness. My pepper is blazing red. I don't know. Maybe a few years ago. But anyways, this would be an example of where we take ordinal data like 5, 4, 3, 2, 1, and they actually do a numerical calculation because they make an average of that, right? So we can kind of take ordinal data and make an average. Now some of the comments can be very hurtful. The most hurtful one about me, which was a few years ago before I started losing hair and stuff, is, and it was pretty biting because it was kind of true. He said it looks like a large 14-year-old boy. That was that was one of the first comments I got when I first started teaching. I'm like, wow. They're kind of fun to go through, but it does look like my last one is what? When was that? That was July 28th, 2015. It looks like most of the ratings are old. They're like 2006, 2004 when my chili pepper was brighter. Kind of flamed out though. So data is very useful, can be very, very, very informative. So now that we know the types of data that we have, okay, now we're going to learn some techniques. Okay, so the first technique, let's go back to the PowerPoint slides. Okay, the first technique we are going to learn is what do we do when we have nominal data? Okay, nominal data is categorical data. Remember, I can't figure out means or medians or modes or variances. I can really only count the number of occurrences I have. So when we have that type of data, I can only count it. So the things that we're going to create is tabular format, is we're going to do a frequency distribution and a relative frequency distribution. So I'm just making this data up, but assume I went around here and I looked in and I said, all right, gender, okay, which is nominal data, and there's 30 of you, and let's say the males, let's say there's 18 males, and the females, there's 12. So this column would be frequency, Okay, there'd be a total of 30. That is a frequency distribution table. That's it, right? Count the number in every category. A relative frequency distribution basically says turn it into a percentage. So if we look at this, right, 12 out of 30 is 40%, 18 out of 30 is 60%. Those are the first two ways, and if you've seen it before, that's how we present nominal data. Frequency distribution and a relative frequency distribution. We're going to create these in Excel in a moment. We also, these are tabular methods, right, because they're presented in a table. Well, how do we represent this graphically? Like if I want to represent this graphically, there's a couple options I can do. What is one option, Stefan? X and Y, what do you mean by X and Y? Put it in a what, I'm sorry? Graphic line. So that's my X and Y. How would you represent this? So I want to know that there's 18 males and 12 females. I'd go with what? The bar graph, right? This is the male bar, and this is the female bar. This is 18, and this is 12, right? And this is a bar graph, right? We've all seen bar graphs before, yes? So bar graphs kind of are very good at representing that first column, that frequency column. How about that second column, relative frequency? If I want to show it as the mix, bar graphs will work, but what's better to show the mix of the whole? Very good, a pie chart. So if I were going to highlight this, I would show it as, I'm not good at pie charts, but it's not good. But anyways, this would be male, and this would be female. That's probably not drawn to scale, but you guys get the picture, right? So here's what we're going to do. I want you, like you guys, to bring up your laptops, right? I told you to bring your laptops, so get out your laptops. And if you didn't bring your laptop, shame on you, but please share it with someone else. Oh, by the way, how many people in here have the older version of laptop, the non-silver one? Okay, you guys are going to have Excel 2013 on there, not Excel 2016. I talked to Nick Weekland over in the library, the first floor of the laptop help desk. You can go over there at any point, no appointment necessary, and they'll upgrade you to Excel 2016. I think you should do that, just so we're all on the same page and using the latest software. Okay, so just go over there anytime this week, early next week, and they'll upgrade you to Office 2016. Yes, sure. Okay, so the marketing manager, this is the one we're going to work on. We're going to create all four of these things, and I'm going to go slow today, maybe annoyingly slow, because I know some people have never used Excel before, very limited, but typically I don't go this slow, so I apologize. The marketing manager of a major brewery wanted to analyze the light beer sales among college and university students who do drink light beer. A random sample of 285 graduating students was asked to report which of the following is their favorite light beer. 1 is Bud Light, 2 is Busch, 3 is Coors, 4 is Mick, 5 is Miller, 6 is Natty, and 7 is Otto. Okay? It says construct a frequency and relative frequency distribution for these data. First off, what type of data is that? Why do you say ordinal, Mr. Boyd? It's definitely categorical, but why do you say ordinal? You have to have a reason it's ordinal. So you would say then what? Nominal, yes? Because you might think Bud Light is better than Busch Light or better than Natty, but it's not universally understood. There's people that prefer this, right? And most of them are rather important, right? So it's not universally understood. So we need to get the data. I'm going to show you how to get the data. So go to Blackboard, and this is where we're going to pull all of our data from. If you go to Book Excel Files on the left navigation, you guys see it down here? It's kind of toward the bottom under Quizzes. You guys find it? Book Excel Files. And then go to Course Text Excel Files by Chapter. And then go to Chapter 2. Go to Chapter 2. And I want you to bring up example problem, chapter 2(1). Okay, that's the way this is. They use this is like XR is an exercise, XM is an example, and then they have the chapter and the problem. So this is example from chapter 2, problem 1. Okay, so click on that, and it should open up in Excel. Now, I don't know, does that come up? Yeah, okay, great. So I don't know if you noticed, you see at the top there it says XM0201-XLS, and it says compatibility mode. What that means is that's an old Excel file. That's from like 2010. So, because that's when the book, I think last had these files done. So some of the functionality of Excel 2016 is turned off because it's an old version. But what we can do before we start doing any work is we can upconvert it. So I want you to go to File, and you see this compatibility mode has convert and an up arrow. You guys see that? Click on that button, and it's going to say, do you want to do this? Yes, I want to do it. I'm going to click OK. Do you want to do it? Yes. And I don't know if you noticed, what it did was it reopened it, and it saved it. See, now it has XLSX, because that's the latest version. That's 2013, 2016 version of Excel workbooks. You guys with me? Okay. All right. So think about it. We took this survey. I'm going to make this a little bigger so you can see it. We took this survey, and the first person said, I like Bud Light, so we recorded a 1, and they were female, so we recorded a 2. The second person said, hey, I like Bud Light too. They told us they were male, so we recorded a 1. Next one said, hey, I like, I don't know what 5 was, but let's say it's Mick Light, and they said they were a female. So this is like the results of our survey, made-up survey, yes? And if I go down to the bottom, and let's go down to the bottom just to see how much data I have. And the way I go to the bottom, I can scroll down. You guys know how to scroll down, right? Or what's even better is hold the control key down and hit end. And that'll take you to the last row with data in it. Control, and hit the end key. Sometimes you have tens of thousands of rows. And I'm going to go back to home by control home. So end home. So I see I have, it goes down to row 286. So that's good for me to know. Okay, the first thing I want to do is, this is the raw data, and I want to count the number of people that said Bud Light, all those good things. So I'm going to build a little table to do that. And I'm going to come over here, and let's go into E1, and I'm going to put responses. Just type responses. And the responses are 1 through, what is it, 1 through, I lost it, 1 through 7. So I'm going to put 1, 2, now I like to do things as fast as possible in Excel because my life, time is limited. So if we then highlight 1 and 2, and we go to the little corner, you see the little box down there, and we left click, hold down and start dragging down, it's auto-filling that for me. You guys notice? I could type 1 through 7 if I like, and I let go of my mouse and it puts 1 through 7 in there. So what I did, that's called auto-fill. So 1 and 2, go to the mouse, go to the square, start dragging down, let go at 7. Which is nice too, because it'll do it for like other things that it recognizes, like if I did January, February, and obviously if I want to do all the months, I would have to type them all out, but it would recognize that. Other things like student 1, student 2, and it recognizes patterns for the most part, so pretty nice, huh? Okay. So you have responses 1, 2, 3, 4, 5, 6, 7. Now that would be a bad graph because we don't know what 1, 2, 3, 4, 5, 6, 7 is. So let's put in F, let's put brand. And then let's write the brands. Okay, Bud, Bush, Coors, Michelob, Miller, Natty, and other. And so we're starting to build this table. Okay, let's go to G1 and put frequency. Now what I want to do is build a frequency distribution table. So if I wanted to know the number of people that said Bud, if I had to do this manually, which I would never do, I would have to go through that column B and count the number of ones I see, right? And then put that number there. If I have 40 ones or 52 ones, I'd have to put that in there. I don't want to do that. So what's nice about Excel is there's a lot of built-in functions, and one of those functions, well, let's go in there and put equal. Equal tells Excel I'm putting a formula in you, and type count if. So count if is the function. We're going to say equal, type count if, no spaces, open parentheses. In an Excel formula, you never use spaces, right? So equal, count if, open parentheses. Make that bigger. I see some people squinting. Okay, so when I open parentheses, Excel is very intuitive. It says, hey, here's the two things, the two parameters you can put inside here. The range you want to look at and the criteria you want to count. Well, where do I want to look? I want to look in column B, starting in what cell? B2. So I'm going to say B2 through, and the way we do ranges or arrays in Excel is we use a colon, no spaces, B2 through the bottom, which is B286. And you'll see automatically it's highlighting B2 to B286. Comma, it says what's the criteria? I want it to count ones, so I'm going to put a 1 in there. And then end parenthesis. So count if B2, B286, comma 1, count the ones for me. If I hit enter, it should come back and say 90. Okay, does it? Now you notice, you guys with me? Okay, if I go back to that cell, you see it's in ready mode. You see down the bottom corner it says ready. Okay, I'm going to change it so I can either double click on it, which puts it in, you can see down the bottom corner it says edit mode now. You guys see that edit mode? Or the other way I can put it in edit mode is use the F2 function key. We'll put it in edit mode. You guys with me? All right, and the reason I want to put this in edit mode is I could do this 6 more times. I could write count if, B2, B286, count the 2s, got to write it again, count the 3s, count the 4s, but I don't have time for that, right? So what feature of Excel should I use to do that? What do you think I should do to replicate it many, many times? Copy and paste, drag it, something like that? Okay, let's do that. Okay, let's copy and paste. I'll show you every way. So if I want to copy it, I could go home, click the copy button, and paste it. I could have done this. I could do Control C, which copies it to my clipboard. Control V, which copies it down there. Which I would do, is drag it. Someone said drag it, go to the corner, left click and drag it down. Whatever I do, though, I'm going to have issues, right? Because if I look at Bush, couple things are wrong with that formula. Give me one thing wrong with that formula. I want to count Bush, what's wrong with that formula? Go ahead, Sophia. Okay, it's still counting the ones, so I could go and change that 6 more times, but I don't have time for that, so I want to fix that. And what else is wrong with it? Tony? What's that? The range. Excel automatically uses something called relative addressing. So when I copy it down a row, it adjusts all the formulas in a row. And I know better in this case, I don't want it to do that. So I'm going to go back, I'm going to delete that, and I'm going to go back to my original formula and make a couple changes. So first off, I don't want to count the ones when I copy it down. I want to count the twos. So instead of hard coding a 1 here, I'm going to put E2 in there. I'm going to refer to a cell that has a 1 in it. So I'm going to say instead of hard coding a 1, I'm going to say count E2. Now what's beautiful about that is when I drag it down, it's going to change E2 to what? E3, and what's in E3? A 2. So it's automatically going to make that adjustment for me. Make sense? Yes, makes sense. The other thing I want to know is I don't want B2, B286 to adjust when I copy it down. I want it to lock that in. The way I do that in Excel is let's highlight just that portion of the formula. Like highlight it, left click, drag, like highlight that. So I just have that highlighted. You guys got that? Yes? Now if I want to make it absolute, I'm going to use the F4 function key. And you notice when I hit the F4 function key, and you guys might have to do FN. You have an FN key? Yeah, you have to do your FN and then looks like turn off the mic. Okay. Does it work for you, Sydney? Okay, it puts dollar signs around that. What that says is lock that in. Okay? If I hit the F4 function key again, it's kind of like a toggle switch, and now it says, hey, lock in the rows but not the columns. Go adjust the columns. If I hit it again, it says lock in the columns but not the rows. If I hit it again, it says don't lock anything. If I hit it again, it says lock everything. You know what I'm saying? So, and that's probably what I want in this case. Let's just lock it all in. You guys follow? Yes? You good? So it's going to return the same thing, but now when I drag it down, because I made my formula correctly, you look, and now it changed, it left B2, B286, it left B2, B86, but now it's counting the 4s, it's counting the 3s, all those good things. You guys with me? Yes, JR. It says true. You have hit enter. We'll go here and plus. Seriously. What that plus? Highlight this use a function. Highlight B2. No, you gotta highlight. It's not. Yeah. Okay. So the other thing I think we should do is let's total this. So I'm going to skip a line and write total. Total. I don't know what I hit caps lock by accident. Total. And there is a function that sums everything. It's called sum, crazily enough, right? So I could say equal sum G2 through G8, and it'll take that range and sum it up I hit enter and I'll say 285. But you know what? Once again, keystrokes in my life are limited. So I'm going to go to G10 and just hit this little deal up here. You see this auto sum button. And it's going to say, oh, you want to add this column? It looks like that's what you're trying to do. You're right. So I hit enter and it adds that column for me. Okay, so the auto sum. Now a couple things wrong with this, or not wrong with it, but not nice. I don't like those decimal points. You guys like those decimal points? I certainly don't. So let's highlight that. And under the home tab, under the number control, I can get less of those or more of those. I want none of them. I'm going to center this thing. Looking better. You notice my frequency kind of doesn't fit. You guys see how it's like doesn't fit? You guys see what I'm saying? If I go between G and H, I can drag that bigger or smaller. And here's what's really nice. This is a time saver. If I go between G and H, when it turns into the cross there, if I double click, it auto fits the biggest thing in there. You know what I mean? Just double click and it'll auto fit whatever the longest thing is. Does that make sense? So all we've done to this point is build a frequency distribution. But now, think about it. I just had a bunch of data. Now I have some information. Mark, what's the most popular light beer among college age students according to this frequency distribution table? What's the least popular? We have information, right? You know something. Michelob's Old Man beer, right? So, very good. Now, beside it, let's build and I want to make that a little bigger. Let's build a relative frequency column. That is a relative to the whole, what percentage is in this category. Relative to the whole, what percentage is in this category. So 90 out of 285. So as a percentage, I need to say 90 and divide it by 285. So I can do that. I can say equal 90 divided by 285. And it puts in there 0.3, which is right, but not really what I want. But that's not a good way to do that, so I'm going to delete it. Whenever there's an option, instead of hard coding numbers in Excel, always use references. So instead of saying 90 divided by 285, how should I put this in, this formula? Rachel? Whatever lives in G2 divided by whatever lives in G10, which is 90 divided by 285. So I'm going to say G2 divided by G10. Okay, equal G2 divided by G10. Now, I know I'm going to copy this down. You guys know I'm going to copy this down. I'm going to drag this down in a minute. Before I do that, I got to fix it. So what part of that formula, Jonathan, should I make absolute? So it doesn't change when I copy it down. Because I always want to divide by G10, right? I want the G2 to become G3, but I want the G10 to stay the same. So Jonathan, what key are we going to use to do that?
Yeah, I'm not sure.
Okay.
Pretty lost.
Oh, I'm sorry to hear that. You look like you were, that's why I called on you, because you were like locked in.
Lost you on the first day.
Really?
Yeah, my computer's not really good.
All right. How many other people were lost? Jonathan, I'm not even like helping you out. Like if I was in this class and I really wasn't lost, I would put up my hand so Jonathan wasn't alone. But you guys aren't as nice as me, I guess. So Jonathan, I'll help you after class if you'd like, okay? But let's make G10. Oh, darn. What did I do? Oh, I know what I did. I pretended I was you and I used the function key. Let's make G10 absolute with the F4 function key. And now we're going to drag that down. Let's auto sum that deal. Still some issues. That looks like hell because we want it to be percentages. Those aren't percentages. So I'm going to highlight those values. under Home tab, under the number grouping, there's a percent style. Let's use it. In this case, let's go another decimal place. And let's center that thing. Under the Home tab, under the number grouping, you see this little percentage, Mr. Boyd?
Yeah.
That'll do it. Highlight it, and that'll do it. This will give you more or less decimal places. Huh? The what's your question, Michael? I can't remember. You need a decimal point. So see by up here in the number, there's move your decimal place right, move your decimal place left. Give you more decimals, give you less decimals. Now I have even more information, right? Once we're at data, I can say, of the people I polled, 8.8% preferred natural light, okay? I can say 31.6% preferred bud. What's wrong, JR? He's lost. Help him. All right. I'm trying to think. I don't want to go halfway into something and then zeros? What are you talking about? Oh, same way. That little decimal place button. Yeah, same way. All right, so a couple things. Now, I have this information. I can take this table, I could copy it, and let's say I am producing for my boss some information on the beer cells. I could go into like Word. I could paste it in there. I'd probably paste it special. I'd paste it as like a bitmap that's like a picture. So now it's like a little table that it's like a picture now, and I can make it bigger and smaller. I could paste it as a bitmap into a PowerPoint presentation, right? If I was presenting to a board or something like that about about beer cells. I have those kinds of options. I could also, I could highlight aspects here. Maybe I'm talking to the Coors Board of Directors, and I want to highlight, what Coors is doing. I could highlight that cell. There's other things we can do. So here's what I'd like you to do for homework. I know I'm letting you go early, but we didn't get to the graphing, but we only have 8 minutes left, and I know the graphing is going to take us like 20 at least. So I don't want to, and Jonathan's lost, so I can't go much further. But here's what I would like you to do for homework for Tuesday, I guess it is. So you have Sunday night, you have to watch, by Sunday you have to react to that video. You guys remember that assignment? Okay. And then for Tuesday, on pages 30 to 33, I would like you to do, we did number 1 already in class. I'd like you to do number 2. And then I would like you to do 14 and 15. But for 14 and 15, all I'd like you to do is create, with Excel, a frequency and relative frequency distribution. Okay? A frequency and a relative frequency distribution. I didn't go through the graphing of those yet. We'll do that on Tuesday first thing. So number 2 and number 14 and 15, Excel, you're going to create a frequency distribution and a relative frequency distribution.
Read it, but then I'll.
It is.
Oh, I see.
By the way, I recorded today, and I do have a 2016 YouTube lecture captures, and I will put this video up there. So if you want to go through it again, like what we did in class, just pause me, because, those kind of things, you can do that, okay? So have a great day. Good luck to all the sports teams competing. Don't go too hard because it's the first weekend. Don't win the whole semester.
There's a lot of like buttons like that. F4 is like the camera.
All right, okay.
Yeah. Her name is Dr. Sheila. She's down this hall to the left. That's what he told me, yeah. Yeah, there's a
Is there clear upstairs?
There's going to be, I don't know if it's there yet. They're supposed to be in the second floor, turn, on the ground floor turn down there, but I don't know if it's hooked up yet. Check it out, sorry.